math. When you have linear factors non-repeated, when you have linear factor repeated, and when you have complex. Okay, you say, now I recall this idea. In this case, the factor and the denominator is linear, it's obvious, right? It's x minus 2 and x minus 4, linear. Of course, non-repeated. You say our partial fraction decomposition format is you copy x minus 2. Doesn't matter the order is not important. And you put a and b. A and b. Okay? Now, the next step is find the least common denominator. Okay, obviously, is both together. And you, in this crucial moment, you multiply the entire expression, the entire equation, because we have equal sign, by the least common denominator in order to eliminate the fractions. No fraction anymore. So we have x minus 6 equal a times x minus 4 plus b times x minus 2. So far, everyone follow me? So you have one equation equivalent to the original, except that this equation has no fraction anymore. It's linear equation. Says, and no linear is a horizontal equation, no, without fraction. No numerator, denominator is only one fraction. No, entonces you try using the smart value. And the smart value in this case, we can, for example, assume 4, because I know when you plug in 4 here, 4 minus 4 is 0. This is 4 minus 6 is equal 8 times 4 minus 4. There's 0. It's gone. That part is lost the intention of the smart. Plus b times 4 minus 2. So 4 minus 6 is negative 2. And 4 minus 2 is positive 2. Therefore, it's obvious that b is negative. Likewise, si yo suppose que x now is positive 2, I come back to our important equation after the multiplication by the LCD, and just bring down this. And now it's 2 minus 6 is equal a 2 minus 4 plus b times 0, no? 2 minus 2 is 0. We have negative 4 equal 2 minus 4 is negative 2. A, therefore, so A is positive 2. No? Now our final answer of the partial fraction decomposition is, you erase A and B because we found A is 2 and B is negative 1. So you put a negative 1 here, either way. Or another student says, no, I don't like this. I put a negative 1 here. Okay, it's perfect equivalent. And this is my beautiful final answer. Any question, guys? How do you feel in that part? How do you feel? Somebody changed the format. No, I don't like this. Grid view. Good. Okay, Rebecca, something wrong happened when your computer gets flashing the screen. Maybe you activate the microphone, no. The camera. Allison, activate the camera. I want to see your face. Allison. What happened? No, nothing happened. I see your window flashing. I don't know why. I mean, does Allison don't want to show me your face? Okay. David, Giselle. Okay, cool. Benjamin, Guadalupe, no face. Jonathan, David, Jamie, Michael, Leija, Daniel, Gustavo, Gustavo, Daniel, Gustavo, Sumondri, Gustavo. We have 2 Gustavo. Ardila, Jose, and Sebastian. Okay, another guys. All right, let me see the face. Benjamin, Giselle, Jocelyn. Okay. Okay. Sydney. Okay, cool. No problem with the first example. Everyone understand very well? Say something. Yes. Okay, cool. So now, okay. I suppose you see my whiteboard, no? Let me erase everything. Let's move on to example 9. You see my whiteboard, right? You feedback because maybe I'm not sure if you see or not. Suppose 4x squared minus x minus 13 divided by, alright? In the chat, say something. I can see. Cool. X parentheses x plus 1 and x minus 1. Okay, this is easy because already the polynomial in the denominator is expressed in factory form. So somebody do a favor. Entonces now the factorization and is linear, non-repeated. So it's linear, non-repeated. Entonces the factorization maybe is using x plus 1 and x minus 1. Remember, the order is totally irrelevant. When you call ABC, entonces now the order you stay one specific order, no? Okay. And the LCD is the three factors together, no? Because we have no repetition. And when you multiply the entire equation by this, multiply, get the action. Well, we have in the left-hand side 4x squared minus x minus 13. In the right-hand side, we have a times x plus 1 times x minus 1 plus b times x multiplication by x minus 1. Plus c multiplication by x again, is another factor that's not included inside the denominator of this part, multiplication by x plus 1. And we have elegant equation, no fraction anymore, and be ready to find a, b, and c using the smart value. It's obvious that the smart value are 0, okay, 1 and -1, I suppose. But let me do one by one. Suppose x0, entonces we have minus 13, because that part is 0, 0. You mentally replace x for 0, and this is 0, this is 0, that part, 0. 0 times something is 0, and 0 times something is 0. And stay alive only a, 0 plus 1 get 1, and 0 minus 1 get -1. Entonces my equation look like that. Minus 13 is equal to minus a. Therefore, it's obvious that a is 13. Okay? Now another smart value is positive 1, maybe. When you plug it in our original equation, positive 1, what determines what multiplier by a, b, and c? Okay, cool. This is a good question. The idea is you select the smart value. So the selection of the smart value depending of the factors. So for example, I know, using my eyes, that when you plug it in here, 0, and plugging in 0 here, disappear that part. This is the idea behind the smart value. And stay alive only the a. So basically, this is to determine a. But in 1, when you plug in 1 here, and 1 here, it's obvious the 1 minus 1 is 0, and the a part and the b part disappear and stay alive only c. So this is using to find the c. Using my common sense, I suppose that -1 is the value okay, you plug in order to find the B, okay, the other, right? This idea was clear? Oh, no clear, Janice. Okay, Janice, you see, okay, focus it, please, in this expression. This is super easy. So the thing you don't see is trivial. I understand that you don't see, but it's trivial. We have one long equation, but this equation is formed by factors. Because this is factor, 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 and also B and C and B, A and B and C is also factor, no? So I try to find the X value such that when you plug in this factor, at least one disappears. So I see, wow, X equals 0. When you plug in here, let me use my red color. 0 here, and 0 here. When you multiply 0 times something, I don't care, B, C, I don't care, or X minus 1 or X plus 1, that part disappear. And stay only the A coefficient, and you plug in, of course, 0 here, and 0 here, but 0 plus 1 is 1, it's exactly this one right here, and 0 minus 1 is negative. Now, what's clear? Yes or no? Answer me, please. Okay. Likewise, when you, I think so. Okay. So now, likewise, when you plug in, so when you assume X equal 1, okay, I come back to my equation. It says 4 times 1 squared, so 1, minus 1, minus 13. Es obvio que this is 4, minus 1 is 3, y minus 13 is negative 8. Okay, in the right hand side. In the left hand side, sorry. In the right hand side, when you plug in 1, it's obvious que that part disappears, 0, because 1 minus 1 is 0, and that part disappears, so no A, no B anymore, and stay alive only C, but see how? C times 1, because X is 1, no? C times 1, parenthesis, 1 plus 1. 1 plus 1 is 2. Times 1 is 2, entonces my equation look like minus A is equal to C, therefore it's obvious that C is negative. Now, more clear or no? It's negative 4. Negative 4. Bueno, negative 4. ¿Es igual o no? Déjame ver, let me check it. Minus A or minus 10? Oh, look, I did too fast. I'm supposed to make a mistake here. Okay, this is 4 minus 1 minus 13. 4 minus 1 is positive 3, minus 13 is minus 10, and minus 10. Entonces, well, you erase, no, minus 8 is minus 10, and when you divide it by 2 is negative 5. Yeah, you follow me, because sometimes I make a mistake. I'm human, remember, I'm not superhero. Now, let me see. I want to see. Janice, Miss Norris, you Do you get the idea? Now, and the second, no?
Yes.
Okay. And the third, I suppose is -1 by the same reason, and this allow me maybe find the B value. Why? Because when you plug in -1, look what happened. That part is 0. How do you know it's 0? Because -1 plus 1 is 0. And here is 0. -1 plus 1 is 0. And this no. Because -1 minus 1 is, I suppose, it's -2. Just allow me to find the B. Okay. Oh, I copy 4 times -1 squared. Be careful with the sign. One sign, screw up everything. Minus -1 minus 13 should be B. A and C disappear. B times -1 and -1 minus 1. Something like that. In that case, -1 squared 4 is 1 positive times 4 is positive. Double negative becomes positive. Actually, 4 plus 1 is 5 minus 13 is negative. This is -8. In the right hand side, we have -1 and -2 because -1 and -1 together is -2. So says possibly 2b. Therefore, b divided by 2 both sides is negative. Therefore, our final answer is A13. B, -4. Some people prefer just replace B for -4, or you put a negative in the front, either way. And C is -5. Boom, I finished. This is my finals. This is the partial fraction decomposition. Maybe the question will fly in there. Well, professor, what is the application of this? This is in calculus.
Professor.
Go ahead.
Isn't it supposed to be 4? B is supposed to be +4 and not -4.
I suppose que no, because it's -2 times -1 is +2. And here, obviously, it's -8, no? When you divide by 2 both sides, -8 divided by +2 is negative. Are you clear?
Oh, okay, yeah. I didn't see the -1.
Okay, cool. Okay, does everyone follow me? So far, everyone get 100 points in the test? Oh. Okay, let's do it one more. Because it's the same stupid repetition. No? 11 and 12, in order to save time, I want to write the format. I want to solve in using Wolfram Alpha, no? Because it's too long. And you see the process in the video on YouTube. Not in this video, but in another video with the solution. Do you think I have another video with the solution of the review package? Everyone is clear in this idea, no? Yes or no? Yeah, you said it's a yes. Guy, everything is clear, everything is easy, in my opinion. Of course, you need to dedicate time with me. If you want to get good grade, no? If you want to get maybe C, okay, just say it's up to you. Okay, let's move on to example 10. I want to do by hand also 10 yes. 10 is 80 minus 14x divided by x cubic minus 8x squared plus 16x. Wow. Wow. In this case, I saw that the polynomial and the denominator of this rational function is not already factored. So I need to do that. So we have one extra step in which you factorize. If you want, you copy in one corner of the piece of paper. And I want to dedicate to do the factorization of this trinomial, no? Entonces, remember the strategy of the factorization is always the same. You find first GCF. The GCF I see using my eyes is x. So you see x squared, and x cubed. GCF is x. Entonces we have x squared minus ax minus 16. I think no, because I continue factorization of that trinomial. Okay, by the way, is suppose que I don't know two parentheses, I put a variable is x, and the combination that opens the door of this factorization is 4 and 4, because 4 times 4 is 16, and 4 plus 4 is 8. And but I make a mistake. This is plus, I copied wrong here. Sometimes lastly happened that I forgot to change. This is minus. Okay, actually the best way to write this, or the elegant way, is x minus 4 squared. Okay, so now I prove this original problem much better is expressed using x times x minus 4 squared. And this is the beginning of the other problem. You have to take the polynomial and the denominator totally factor out. Factor. Now so we have linear factor but repeated. So now you break it down, this no in 2 partial fraction decomposition, no in 3. Why 3? Because one is for x, another is for x minus 4 linear, so no square power 1, and the last one is x minus 4 square. This is the format for the partial fraction. You need to know. This is important for me. The rest no, but this is important for me. And you call ABs. ABs. Suppose in another scenario, you see in the next one. How is the last one square? Because when you have any power 2, 3, 4, 5, you copy the same and you decreasing the exponent. See 2, I suppose that we have 2 partial fractions using 2 and using 1. So you have 3, you copy x minus 4 cubic, 3, x minus 4 square, and x minus 4, 1. 3 times. You see in the next example. This is the thing you have to remember. This is the, the typical cases of the partial fraction decomposition. Was clear my answer or no? Or no? Now let's common denominator. This common denominator is x minus 4 squared. I recall quickly, the least common denominator is the collection of the every factor that we have in our problem, but when the one factor is repeated, what means to be repeated? X minus 4 and x minus 4 squared. You take the majority of this. Okay, majority. This is the idea behind LCD. And you multiply now this expression by LCD. Multiply. Entonces we have 80 minus 14x. Okay, cool. We have 8 times x minus 4 squared. When you multiply, it's obvious. One mnemonic divide. You copy the factor that we have no. And the denominator, you put in the numerator. Plus b, in this case, x and x minus 4 linear, no? Because we have one, x minus 4 cancel out, but the only one, x minus 4. And stay obviously x and x minus 4 to the power 1. Plus c x. Boom. So far, everyone follow me? And this is my super important equation. This is my super important equation. Yes. Okay, super, no risk. Okay, entonces I am smart, or I try to be, and using the smart value. So one super easy smart value is 0. Because when you assume 0, it's obvious that that part disappear and that part disappear and stay only alive a. Entonces x equals 0 is easy. It's just 80, no? Because 14 times 0 is 0, there's nothing. And stay a 0 minus 4 squared. And 0 minus 4 is negative 4, and negative 4 squared is positive 16. Therefore, divided by 16 both sides, AFI. Okay, at least I have in my hand that coefficients. Fine. Another smart value I can see clear is 4. Because when I plug in or assume x equals 4, it's obvious that this guy is going 0, and this guy is also 0, and it stays C on. Okay, let me try. So you have 80 minus 14 times 4. You replace x for 4. Equal. No A, no B. Just C times 4. So now 14 times 6 is 56, I guess so. Let me check it in my calculator. 14 times 4, oh yeah, 56. Subtracting 80 is 24. It's 24. 24, of course, positive. Equal 4C, I copy the coefficient first. Therefore, the C is 24 divided by 4 gets 6. Yeah, it changes. Positive 6. But we have no more smart value. Okay, but we almost finished because I need only one coefficient to get B. Therefore, you assume arbitrary frame value. I like 1 or 2 or 3 or negative 1 maybe, I don't know. One easy, not complicated. If you plug in x equals 1, it's 80 minus 14 times 1 is equal, well, a 5. 1 minus 4 squared. Plus b, no idea. B times 1. Because x is 1 and 1 minus 4, no? I indicate after I compute step by step. And C is 6. 6 times 1. Okay, this is 14 times 1 is 14. 80 minus 14 is 66. Is equal. 1 minus 4 is negative 3. Negative 3 squared is positive 9. And positive 9 times 5 is 45. Plus or minus, I suppose, because 1 is 1. 1 minus 4 is negative 3. So actually, it's minus 3b. Plus 6. Okay, super easy. 66 minus 45 minus 6 is equal to minus 3b. This is, put it in a calculator, it's 15, I guess so, 15, yeah, 15, yeah. But well, okay, because 66 minus 6 is 60. 60 minus 45 is obviously 15. 15 is equal to minus 3b divided by 3b both sides. B alone is negative 5. And we finish. I only erase the letter B and the partial fraction decomposition. I put negative 5. But at this moment, to practice both situations, I put 5 and negative. It's equivalent. I suppose that you are aware. Guys, the beauty of this is that this expression is equivalent 100% of this. Algebraically, 100%. Identical. Identical. It's identity. Now, this is super hard working in calculus with this, and it's a super easy step by step, separate. Because the majority of the linear operator in calculus are linear, and you can separate. You can separate. So you have, for example, different expression connecting by plus or minus. You can apply the calculus operator separately in this expression, or in this expression, or in this expression. And this is the beauty of this method. I suppose that the teacher explain calculus 2, no 1. This is an excellent calculus. Remember, this precalculus is the algebra, complementary algebra that you need to know to face calculus. Calculus is different, it's another branch of the mathematics, another different branch. It's another thing I don't want to anticipate, but our problem right now is the algebra behind the calculus. Okay? Any question? No problem. No? Rebecca, everything okay? Yeah. Benjamin? Cool. Rebecca is good. Okay, cool. No question. Okay. Now let's go move on. But this is super. So 11 and 12, we are doing differently. Basically, I want discussing the format for the partial fraction, and the computation of this is too heavy. Guys, let me explain something. In mathematics, they are complicated things, but they are heavy. What is the difference between heavy and complicated? Complicated is conceptually hard to understand, but complicated is easy. You know very well the procedure, but it's too long. And you spend, I don't know, 2 days doing this problem, because the fault of this is the too long. And when it's too long, everyone, even me, make one stupid mistake. I change one sign, I screw up everything. So you never get the final answer correct. Okay, that is the reason. Nowadays we have software, no? You want to show it to the teacher. Okay, I want to show it. But your verification with the software, no? It's the same answer. So I don't make mistake in the long process. Okay. Okay. Suppose 11. 11 say 7x cubic minus 2 divided by x squared x plus 1 cubic. Okay. How many partial fraction decomposition we have? I have no idea. I suppose the 5. Why 5? Because we have, for example, for the factor x squared, we have 1x and 1x squared. Yeah, I finish. I call A and B. For the factor x plus 1 cubic, I suppose we have 3 more. We have x plus 1. We have x plus 1 squared. And we have x plus 1 cubic. And we have, well, C, D, and E. This is the format. This is too long. Too long. Let me try to do at least the part of the least common denominator. Okay, obviously, the least common denominator is x squared, x plus 1 cubic. And when you multiply the entire equation by this, we have 7x cubic minus 2, and we have 8 times x, because it's stay 1x because it's x squared divided by x, no? And x plus 1 cubic. Plus b just x plus 1 cubic because x squared cancel. Plus c x squared multiplication by x plus 1 squared. Remember, in LCD we have 3, and this fraction we have only 1. That's a simplification of least 1 and stay 2. Plus px squared, of course, multiplication by x plus 1 to the 1 power. I put a parenthesis because, you know, to indicate it's a 1 factor separate. This is D, no? I make a mistake here again. D. And finally E. E times x squared. Boom! That's it. Entonces, to find the LCD, we have basically 3 smart values, 0, 1, and negative 1. No, 0 and negative 1. Entonces, you find maybe one equation. Entonces, you need to use the extra frame value to set out the system of equations, and you finish this stupid problem solving a big system of equations, 3 unknown and 3 equations. Okay. We are doing now using Wolfram Alpha. Okay. But let me try to discussing conceptually number 12, que is similar, is 3x plus 1. This is easier, in my opinion. X minus 1, x squared plus x plus 1. Somebody mail me something, but I don't care because I am inside the lecture. Another student, another class. Okay, look, how you break it down? Well, you have in this scenario, we have one linear factor not repeated, cool, and we have one not repeated also, but irreducible quadratic because the solution for this is a complex. It's a complex. Now we have the format for the partial fraction decomposition is 2, only 2. The first one is for the factor x minus 1. They want to call A. And the second is the irreducible quadratic x plus 1. So you are aware guys, que this trinomial es impossible factorization and using real numbers. And the complex, yes. No. I don't want complex. But this is irreducible. This is called irreducible quadratic expression. Therefore, see the degree is 2, and the denominator degree of the expression of the partial fraction decomposition is 1. So at least 1 less than. This is bx plus. Entonces, likewise, LCD would be x minus 1 times x squared plus x plus 1. When you multiply everything, we have 3x plus 1 equal 8 times x squared plus x plus 1, because x minus 1 cancel, plus parentheses bx plus c times x minus 1. Entonces, now is the moment you start. Guys, don't be scared. Well, you see the test. In the test I put easy. Easy is linear, no repeated. So this is extra because I suppose you need to know for calculus, no? So now I want to show you 11 solving in Wolfram alpha. Because I left to you 12 solving using Wolfram alpha also. Let me try Wolfram alpha. Okay, look. Switching to Wolfram alpha. Do you see my Wolfram alpha page? Yes or no?
Yes.
Yes. Well, it's easy. You copy PFD, partial fraction decomposition, and you copy using natural language, or in my opinion, much better math language, our rational function. And you press that button, bam, and you get that. And the first line, you can see the original. And this is important because they make a mistake in the syntaxis. You verify. See, this is exactly the function I want to break it down, decomposition. And we have 5, the famous 5. 1, 2, 3, 4, 5, and 6. It's 6, no? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. The reason it's 6 is because I copy wrong. I copy, this is x squared. Sorry, I copy wrong. This is not cubic. This is a square. You press this. Alright, let me double check it. No, coño. This is cubic. But this is a square. Eso. Now, bang. There you go. It's 2 minus 2. So I suppose in our expression you have right now in your notebook or in my whiteboard, A is the coefficient associated with the denominator is x to the 1 power, it's 6. That one. B is the coefficient in the x squared, actually is minus 2. C is the coefficient associated with the x plus 1 to the first power, que es negative 6. With 6 negative. X plus 1 squared is the coefficient I call D, que es positive 3. Cool. And E is the coefficient associated with x plus 1 cubic, que es negative. Bang. Final answer. You see that? You have to practice. you have to practice. I propose you practice, review again. You watching the video on YouTube, and you do it solve it by hand, and by hand like I am living in the jungle, without calculator, without internet, you know. But now we can do. But in the test, no problem. In the test, you never see repeated too long process. Okay. Do you want to? Can I do for you number 12? No. Oh no. It's the same stupid thing. What do you think? I do number 12 in Wolfgang Alpha or not? We can skip. I agree. Okay, so let's move on to another topic. Of course, I need to share again the whiteboard. Somebody press the button for the recording. Thank you so much. Whiteboard. Okay, there you go. There you go. Microsoft Whiteboard. Okay, we are doing now 18, no? 18 or 13? 13. Oh, 13 is easy. It's two equations, so one system, non-linear. Okay, it's formed by one equation 1, que is non-linear because it has a square, and one equation the linear, number 2 is the exponent is 1, so that is the reason the linear. No? So my recommendation is, when you have one equation the linear, you take advantage of this, because allow me, for example, take this equation and solve for y. So y is equal -7 minus x. And now substitution, this expression, and another equation, of course, in the y place, here. And you copy x squared plus big parenthesis -7 minus x squared equal to 25. In this moment, I have one equation that contains only one variable, is x. Okay, so now I see that I don't care this negative, I can erase, because any negative number inside the square becomes positive. This is equivalent. Okay, so you don't understand very well this idea. The original is -7 minus x, no? Square. But we can interpretation like a -1 square and 7 plus x squared. And -1 squared is the invisible positive one. This is invisible, don't necessarily write it. Anyone follow me? Now you expand the binomial 7 plus x squared, exactly the same we are doing in pre-calculus, no in kindergarten algebra. Okay, it's square first, x squared plus 7 squared, you square first, plus, because this sign is plus. If this sign is negative the first and positive the second. 2 times 7 times x is 14x plus x squared equal to 25. Everyone follow me? How you expand this? By the way, 7 squared is 49, no? I'm not necessarily right for 7 squared.
I have a question.
Go ahead.
How did you know that you need to put -7 minus x into y?
Well, because I take the first equation. Because I solve for y in the first equation. So y, by the way, if this y is the same of this y, you substitution, and that's it. Do you understand the idea or no? explain a different way, no? But this is classical substitution method. So you take advantage que one equation is linear. You isolate maybe y or maybe x. I need to make a decision, ¿no? Entonces, in my mind, I say, well, oh, I want to isolate y. Okay. And this new expression for the y, you plug it into another equation. That's exactly I did here. No y squared anymore. It's 7 plus x squared. This is your question, mister?
Oh, yes.
You understand my answer, or no? My explanation or no?
Yes.
Uh-huh.
So we always have to single out the y for the second equation.
Absolutely, yes. Okay, so in this moment I have a question. But this is baby algebra. It's a baby algebra, elementary algebra, no? I believe that this equation is quadratic equation, no? Because contain x squared. There are no reason to have separate this x squared and x squared as 2x squared plus 14x plus 49 minus 25. What is the reason I move 25 to the other side? Oh, because I want to express it, that equation in the standard format for the quadratic expression, the quadratic equation. So it's 2x squared plus 14x plus 24, no? Because 49 equals 0. Wow, entonces piece okay. Oh, more. You apply directly quadratic formula factorization. No, hello. You spend 1 second to meditate. Oh, it's even divided by 2, divided by 2, divided by 2, divided by 2. Entonces, our new equation is equivalent to the original. Of course, it's x squared plus 7x plus 12. Wow, this is easy. Not necessary doing by quadratic formula. No. Because it's possible by factorization. So that trinomial, the combination that open the door for the factorization is 4 and 3, I guess so. Because 4 times 3 is 12 and 4 plus 3 is 7, and the sign are positive. The one factor is x plus 4 equals 0. Indicate que the root of 0 is negative 4. And x plus 3 equals 0 indicate that x is negative. But be careful, guys. Little by little. Don't confuse. Try to organize your work. Because remember, we have two variables, x and y. We found two values for x. Now, I suppose that we have two values, or not necessarily always a 1 to 1. But in this case, suppose that you take this statement, x equals negative, and use substitution in order to find the y value in either equation. Of course, I am smart, and I using this, que es easy. So y alone is minus 7 minus 4. Be careful with the sign. Be careful with the sign. I respect the sign of the equation, but I plug in the value with their corresponding signs. This is minus 7 plus 4 is minus 3. Therefore, my point solution is negative 4, negative 3. This is my first. My second, at x equal minus 3, similar. Y is equal minus 7 minus 3. Is minus 7 plus 3 is negative 4. Therefore, my point solution is negative 3. Remember the convention. The first number represents the x component. Shoot. What's going on? In one moment was disconnecting the Skype. Eh? Say something. No audio. No camera.
I can hear you now, but everything froze for a second. At least it did.
So you lost one explanation, one part of the explanation, or no? So you continue to see my whiteboard?
The whiteboard froze too.
All right, somebody explain me well. You see the connection. He was, who he, me, he was what? Jose, explain me something. Mister, you were frozen. Ow. I don't know. And this moment I was frozen is because the connection. I suppose I pressed something wrong. I don't know. Okay, it's easy. Okay, to say, in that moment you see my whiteboard with the solution or no? All right, we can see, we can't. Samiha, you can see. Okay, Samiha. Let me try. Okay. This is my whiteboard, Samiha. Do you see now or no?
Yes.
Yes. Okay, cool. You know, guys, this is some disadvantage of the online class. You have advantage and disadvantage. Advantage is everyone have a home. Look at the one screen of the computer. You can communicate not 100%, but something with me. Okay, do you understand very well the problem 13 or some question? No? My question was, do you want I show you the Desmos to simulation this problem or no? Do you want I show you or no? You feel strong doing this? Come on, I'm frozen now or no? You see my face or no? All right. Say something, guy, help me. Benjamin, say something. Do you want I show you Desmos for the solution for this? Okay.
Yes.
Yes. Say yes or no. Okay, let me try. I suppose here we have. Okay, there you go. Switching. Desmos. Do you see Desmos? We are talking about question 13. There you go. Look at that. Do you see Desmos? Yes or no? Yes. Say something, guys.
Yes.
You see the chat? Yeah. The first equation in blue color is a circle. The second equation is a line in green color. And the connection of point, common point, in purple color. Maybe you don't see very well, but I make a zoom. And when you make a zoom, it's the point -4, -3 and -3, -4. Clear now? Clear?
Yes.
Cool. Let's come back to the whiteboard. Switching to whiteboard. Do you see my whiteboard? Yes, Benjamin. Benjamin, help me. 14. 14 is easy, it's similar. Y equal minus x squared plus 13. It's non-linear equation. But I take advantage que the y is isolated. Entonces, this suggests me que you apply substitution. Substitution method. This is the system. So I see important detail. Y is isolated. If you take this expression and substitution here, and the y of the another equation, x squared plus parentheses minus x squared plus 13 squared equal 25. You follow me? You follow me? Okay. Now we focus on the solution of this. You expand, it's easy. It's x squared plus x minus x squared square. This object is x to the 4th power, positive. Minus, because at least one sign is negative, is minus. 26, what comes from 26 is the multiplication of 13 times extra 2. You multiply x squared plus 13 squared is 169 minus 25 equals 0. Do you understand the thing I am doing? Sure? Okay, so let me organize, because look like at least not quadratic exactly, but a quadratic in front. You copy, organize, and descending order of the degree x to the 4th power I put in the first place, and why not combine like term? Positive 1 and negative 26 is negative 25 x squared plus 169 minus 25 is 144. Equal to 0. Well, in this case, you can use the quadratic formula, but no. I know both sugar factorization. So you don't see, you spend some minutes. So you don't see the factorization, no problem. You apply the quadratic formula and you get the same answer like me. But I prefer factorization because it's easier. Square root of this guy is x squared, no x, because the degree is 4. You just apply square root, it's divided by 2. And the combination that opens the door is 16 and 9, because 16 times 9 is 144, and 16 plus 9 is 25. Of course, the sign is negative both. You have, well, you separate if you want in two quadratic equations and you apply the square root method, one possibility. Or factorization again, because actually this is 2 different of a square, and the factorization is 2 parentheses, 3 parentheses, 4 parentheses, square root this guy is x, x, this is 4 plus and minus, it's a classical difference of a square, 3 plus and minus. Actually, it's a one possibility, guy. Another possibility I like so much that you take the equation like that, x squared minus 16 equals 0, and you apply the square root method. You move 16 to the other side, apply square root both sides, x is equal plus and minus 4, and you get this solution and this solution, because this is x plus 4 equals 0, that is x equal negative 4, and this is x minus 4 equals 0, this is x equal positive. Likewise happen here. Happen here is x squared minus 9 equals 0, x squared equals 9, square root both sides, and so with the x is equal plus or minus. Of course, we don't finish, but we almost finish. Did everyone understand very well the thing I'm doing so far?
Yes.
Now, to find the y value, wow, I'm using the easy case, this expression. This expression I put in red color, remember? Because it's equal y. So, be careful. The organization is you take plus or minus 4. What is the reason, Professor? Can you take both values together? Oh, because I know very well that when you plug in this x and the first equation is y equal negative plus or minus 4 squared plus 13. Because I know very well that it doesn't matter que plus or minus square because positive. Actually, is we have minus 16 plus 13 is equal to minus 3. And this is the y value. But be careful, because actually in this moment we have no 1 point, we have 2 points. Because negative 4 and positive 4 generate 4 comma minus 3, the plus solution, and minus 4 comma minus 3. Then we have 2 points. We have 2x, and we have 1y common, that is negative 3. Okay, now likewise, for plus or minus 3, we have y equal minus plus or minus 3 squared plus 13. Entonces negative 9 plus 13 es 4, pero positive 4. Now you have 2 points, the point 3 comma 4 minus 3 comma positive. So our nonlinear system have 4 solutions. 4 solutions. And the idea is clear. The idea is clear. You have, remember, this is the, okay, let me try to understand the geometric interpretation. We can put in decimal, of course. If you want, I do it now. But basically, Ching Chang, this second equation is a circle, where the center and the origin and the radius is 5. So that distance 5 in any direction, 5, 5, 5. But the first equation, no. The first equation is a parabola. It's a parabola, but this parabola open down because it's negative. It open down like that. And the y-intercept is 13. You're supposed to get this is 13. It's the vertex of this parabola. And the parabola open, and you obtain 1, 2, 3, and 4. Okay, the fourth solution. So the solution you write in the formal way, solution set is 4 comma minus 3, the order is not important, it's a set. Minus 4 comma minus 3, comma 3 comma 4, comma minus 3 comma 4. Bam! Final answer. Solution set. Do you follow me? Cool. Okay. Repetition the question. Do you see Desmos simulation for this problem or no? Benjamin. Wait. Benjamin like so much the Desmos simulation. Okay, no problem. Let's do it. Okay. Let me share the screen for the Desmos. Switching to Desmos. There you go. Do you see my Desmos? This is the problem 14. Look at that. Bang. Okay, the equation blue is a circle. The equation red is the parabola. Up and down. By the way, the vertex is located at the point 0,30. And the solution I put in green color, minus 3,0, minus 3,4, sorry, positive 3,4, minus 4, minus 3, and positive 4, minus 3. Cool? Any question? No? Jose, everything okay?
Everything's good.
Rebecca? Everything okay? Okay. One more. Suppose that I switch into whiteboard. Do you see my whiteboard empty? Because I erased everything. 15. Oh, 15. 15 is easy, Giselle. Look. 15 is easy because is y equal 6x squared minus 5x. This equation number 1. Of course, non-linear. Es separable. And y is equal 2x plus 3. Oh, this is easy. It's linear. However, I want to take advantage. Okay, y in both equations is isolated, totally isolated. Therefore, the y is the same, and you write the equation like that: 6x squared minus 5x is equal to 2x plus 3. Make sense? Equation 1 equal equation 2. The y of the equation 1 is equal to y of the equation 2. I suppose that in this moment I face one quadratic equation. Let me organize in standard. X squared minus 5x minus 2x minus 3 equals 0. Okay, so combine like term. 7 minus 3. Okay, one possibility is solving by quadratic formula on the supposition that A is 6, B is negative 7, and C is negative 3. But I don't like, because in this case it's easy. Remember factorization by grouping, you multiply that number without sign. The sign is not important. It's 18. You analyze the factor of 18. For example, 9 and 2, 6 and 3, 9 and 2, 18 times 1. But 9 and 2 matching perfectly because somehow 9 minus 2 is 7. Which I can do by factorization. You copy. This equation you copy differently. You copy 6x squared and you separate 7 using 9 and 3. And the corresponding sign, minus 9x plus 2x minus 3 equals 0. The only thing I did was separate 7, negative 7, and negative 9, and positive 2. If you put together again, we come back at the beginning. But no, I don't want to come back at the beginning. I want to apply factorization by grouping, and between this couple red and between this couple blue. And the great common factor is 3x. So we have 2x minus 3. And the great common factor in this case is 1, because we have no common factor. 2x minus 2. Let's see. Don't forget equal sign and 0. I saw the 2x minus 3 is a common factor again, and we have 3x plus 1. Oh, nice. We have two factors, we have two solutions. The first one is 2x minus 3 equals 0. Therefore, 2x equals 3 divided by 2. X is equal 3 half, 1.5. Okay, entonces now the second is 3x plus 1 equals 0. 3x is equal negative 1 divided by 3. X is equal negative 1/3. Okay, now, if I want to find, do you see that, or you prefer quadratic formula? Because maybe you're a fan to do using the quadratic. Do you want to do by quadratic formula or no? No? Yes. Shane dice yes. Okay, quadratic formula Shane. Minus b plus or minus square root b squared minus 4ac divided by 2a. The only disadvantage of the quadratic formula is, bueno, que you have to remember the formula, ¿no? Entonces, actually, substitution, plug it in. B is -7, pero the formula have extra negative, and negative together is positive. Plus or minus square root, -7 squared is 49, positive of course, minus 4 times 8 is 6, and C is -3. Divide the whole thing by 2 times 8, 2 times 6. Entonces 7 plus or minus square root 49 plus, because double minus, ¿no? Ajá, entonces I put in my own calculator. 4 times 6 es obvio que es 4 times 6 es 24, ¿no? Times 3 is 72. And 72 divided by 12, ¿no? And 72 plus 49 is 121. 7 plus or minus square root 121 divided by 12. And the square root 121 is 11. Actually, we have 7 plus or minus 11 divided by 12. And you separate in two solutions. The first solution using plus, and the second solution using minus. Okay, and 11 plus 7 is 18. 18 over 12. We can reduce the lowest term. Divided by 6 maybe. Top and bottom is 3/2. Bang, exactly the same as this. And 7 minus 11 is 5. No, 5, no, 4. Minus 4 over 12. Divided by 4, reducing lowest term is -1. Bang. What way you prefer? Quadratic formula or factorization? Maybe you forgot a little bit factorization, no? And this is the reason you prefer. Quadratic, okay, Giselle? No, cool. What is the advantage of the quadratic formula? Que es systematic. You know the formula, you have calculator, don't worry too much for the arithmetic part because you're solving everything in the calculator. Now I'm moving. I have the x value. So at x equal 3/2, I need to find the y value. But the y value, wow, what equation you recommend me using? I suppose get that one. I am smart, using the easier equation, the linear. Entonces now is 2 times 3 over 2 plus 3. Oh, easy, these two is cancelled. And 3 plus 2, 3 plus 3 is 6. The point, the famous point would be the point 3/2, 6. This is the x value and this is the y value. And for x equal -1/3, we're using the same equation, of course, get the easier. 2 times -1/3 plus 3 negative, this multiplication is -2 over 3 plus 3 over 1, no? The 3 is a whole number, right? So now the least common denominator obviously is 3. And then we have -2 plus 9. 9, because 3 times 3 is 9. Entonces es 7 over 3. Entonces the point would be -1/3, 7 over 3. In this case we have only two solutions. Consistent, no linear. Because it's a parabola. O sea, it's logical because it's a parabola that open up. And you have a line, you have two solutions. Using my imagination, no? Geometric interpretation. Guy, I promise, que in the chapter 4, in the chapter 4, we study in details the parabola, the ellipse, the conic sections, the hyperbola, circle, everything. Okay, you need to know very well for calculus. Okay, and so far I try to use in your intuition. How you recognize that this is a parabola? What is the reason que es parabola is because we have y, 1 power linear, and we have x squared. This is a parabola. Si we have 2 squared, entonces maybe circle or ellipse. Si es plus in between, ¿no? So you have x squared and y squared is minus a hyperbola. But si you have y alone, no exponent, is a parabola. Si you have y squared and x with no square, it's another parabola, but a different kind. This is vertical, maybe open up or down. And in this case, maybe open right or left, horizontal. But don't worry now, we discuss in detail in your moments. What do you think about 16 and 17? Just the same stupid thing, we skip or no? Opinion. So you say no, professor, doing, okay, no problem. So I propose you skip 16 and 17. What do you think? No? You said no? Continue. Skip, Jose, because it's the same thing. Everyone is agree or disagree? Okay. So let's move on to the 18. Let me try to find 18. 18 is easy. Okay, 18. 19. Where is 19? I'm supposed to get another page. And 20. Wow, it's super easy doing using decimal. Yes or no? How do you feel in decimal? You are strong or no? Okay, well, one idea. Today, when I finish, the class is over, I will send the video of this plus my decimals, so the link for the decimal in my account. In my account, in that part, and the review for the test number 2. And you can see clear this idea. But just in case you want to see, I don't know, select what you want can I do for you. See 18, 19 or 20. It's similar idea, no? Tell me, guy. 18, it's okay, 18. Or 18 is too easy because it's linear. Or 19, no. 19 is no linear at first and linear at the second. And 20 is same thing, but change the sign maybe. How do you feel in that part, inequality? Remember, the solution for the inequality is graphical. You are doing well, let's do it something. Let's do 18. 18. Entonces I switching, no more whiteboard. Let's switch into decimals. Let's see what happened. Look. Switching to decimals. I suppose you see decimal. You see? The idea was 18. Oh, it's easy. Look at that. I copy one by one. The first no enclosed in the curly bracket, no. But the second yes, and the interpretation of decimal is case and the connection, the logical connection in between each inequality. Bang. And this is the answer. Entonces now maybe the question will fly in the air. Professor, what is this point? I suppose that this point is the solution of the intersection 2 equation. No? So you copy. 4x plus 3y equal 12. So you forgot the greater than. And x equal y. It's obvious. Let me try to do quickly in one piece of paper. So you have 4x plus 3y equal 12. And you have x equal y, because I forgot the inequality sign. I focus in the equation, get the intersection. So obviously we have 4x plus 3x equal 12. Therefore, x is equal to 12 over 7. And y is the same, because it's the same. So see, I plot the point by curiosity. Let me try. Try. Open point, que es 12, paréntesis, sorry, 12 over 7. Coma. 12 over 7. And this is the point. Okay, it was the intersection under the supposition equal sign. Of course, is you have to line is be above the first line, que is this one, and below to this. You see why below is greater than, because remember, to do the graph, you put the y in the left hand side. So when you interchange x and y, you say you change, you reverse it, you flip it, the inequality sign. Guy, do you understand this, or I want to write this information in the whiteboard? Let me know.
Show on the whiteboard.
Okay, cool, no problem, I understand. Okay, let me try. Stop sharing, switching to whiteboard. Do you see my whiteboard?
Yeah.
Okay. The questions say at the beginning, 4x plus 3y greater than or equal to 1. This is my inequality number 1. Now, the second say x greater than again or equal y. Okay. When you put in decimals, suppose let's do it quickly by hand in the whiteboard. Look, you take, in this case, super easy. Determine, for example, xy, 0x, 0y. Si you declare x equals 0, it's obvious que y is 4. But the point is 1, 2, 3, 4. 0, 4. And when you declare y 0, it's obvious que 3. Because 0 here, 3 times 0 is 0, stay 4x equal 12, entonces 3, 0, 1, 2, 3. And this point is 3, 0. And my line, by the way, is solid. And obviously, the region KI shape is above the line. Makes sense, right? Not necessarily. So actually, the efficiency way to do this, to take the equation, the inequality, 3y, you solve for y. greater than or equal minus 4x plus 12. Divided by 3, divided by 3, divided by 3, y is greater than, because you are divided by a positive number, therefore the inequality sign stays the same. You determine b is a y and a z, cool, and from this is 4 down, 1, 2, 3, 4, rise and roll, 1, 2, 3, and you get the same. It's another way to see. Now let's move on to the second, and the second is, well, x greater than or equal y, but I need y isolated in the left-hand side. If you interchange. And when you interchange, of course, you need to switch it. Anyway, it's obvious. The y is 0, 0. Because we have no b here. B is 0. And the slope is 1. 1, 1. And this is the solid again. And you shape below the line. Below the line. See below at that part. But in the part above, solution overlap is this. However, by curiosity, this is the answer I get in decimal. The only thing in decimal you don't need to do anything. You copy the first inequality. This is the syntax. You open this curly bracket and you copy exactly the same. No isolate or nothing. Don't do anything. Decimal allow you to solve it. And you see the green part and the color you want to see. And now I determine this point. This was curiosity. This point. This point is the intersection between this equation. So for temporary, I forgot the greater than symbol. No, it's equal. And this symbol. Okay, this situation is good. Because I know that x is equal y. Substitution here. Entonces 4x plus 3x equal 12. 7x equal 12. X is equal 12 over 7, que es the decimal que you see in decimal. 1.7 something. And y is the same. So this point, this famous point, is the point 12 over 7, 12 over 7. Because x and y is the same, according to this equation. Now you see more clear?
Yeah.
Excellent. So what do you consider is good? Doing another, or let's do at least one problem of the linear programming? Or the inequality is okay for you. It doesn't matter if it's linear or non-linear. We solve in decimal everything. Come on, I need to hear opinion.
I think we're good.
Yes. So let's open at least one problem of the linear programming in the time that we have. The last too much. 5 minutes. Okay, remember linear programming. Linear programming is the optimization problem. Every optimization problem has two pieces. One piece is the constraints, and the other piece is the objective functions. But what is the thing you should do? First of all, you consider the constraint like a one system of inequality, and you plug in decimals, and you try to find the feasible region. Okay, normally it's a polygon. So now you investigate the corner of this polygon and plugging in x and y value of this corner into the objective function, and you need to optimize, maybe maximize or minimize depending on the problem. Suppose that we are doing the question 21 and 22. Let's do them both. Easy. Look, let me switch into decimal, of course. Well, let me try to share. This is the complicated part for me. Stop sharing, switching to sharing, decimals, window. Okay, now open that. Do you see my okay, suppose the question 20 first. Okay. I dedicate for the constraint. This is the constraint. We have three constraints. 3x plus 2y greater than or equal to 6. X and between 0 and 10. It's one compound, actually it's two inequality, but you put together like three pieces inequality. And y in between 0 and 5. And when you plot that, bang, you see the feasible region. And the feasible region in this case is a pentagon. 1, 2, 3, 4, 5 sides. So we have 5 corners. The first corner, I don't know what is the first. I call 2,0 clockwise direction, 0,3, 0,5, 10,5, and 10,0. And we come back at the beginning. Substitution x and y into the objective function is given also. The objective function is 15x. Look at that. 15x plus 13y. Using the table in decimals, you include here, click addition table, and the table is look like similar to this Excel spreadsheet. And you put a value of this corner. For example, 10.5 is this corner. Automatic, as you put equation here, computer gets 215. This is the column important, no? 215 is the C value in this corner. 2,0 is this, is just 30. 0,3 here is 39. 0,5 is this corner is 69, 65. And 10,0 que es this corner is 150. Entonces es obvio que the maximum occur, o sea, the maximum value of this objective function is 215 at x equal 10 and y equal 5. End the story. You say something, mister? Guys, you understand very well this? It's easy. Don't try to see beyond. It's super elementary. Benjamin, it's okay? Giselle? Cool. Jose?
It's good. It's good.
Shane? Okay. We have time to see another more. Yes, why not? It's okay. Remember, when you open my email, okay, send in a few minutes. This is the video for now, plus the decimals. And you take this for the test. Oh, you see, no, a different number, but it's the same idea. Okay, one more. 22 seconds. Look at that. I copy my constraints in one line. 1, 2, 3, and 4 inequality. Together, connecting by and. Bang, I get this. I put a red color, and this is my feasible region. So my solution is inside. I need to try in the table in different corners. 3,2, 4,0, 0,0, and 0,4. Yeah, I investigate que nice. The maximum occur at the point 3,2, que es 32. 32. 0 is obvio que es 0. 28 is this. 4,0 and 0,4, sorry. And 4,0 is 24. And the maximum happen in this because I am doing the graphic to illustrate the idea of the objective function. Look, this is the objective function, and you know this is totally outside the feasible region. No solution. This is yes inside solution, but the optimal solution is the first point que touch the feasible, que es 32. Any question? No problema. Feel strong. So I recall one more time. Okay, these tests do both online and on paper. June 19. Okay, by the way, it's next Monday.